All right, in this video, we're going to take a look at the reflection of light, and especially as it pertains to flat surfaces known as mirrors. And so I'm going to let my friend MJ introduce the concept. All right, so Michael introduced the idea of looking in the mirror. So hopefully you're that excited as this young lady is as you're watching this video about mirrors. And something interesting, when you look at a reflection in the mirror and you see yourself, you actually will never see yourself as present. You always see an older version of yourself, and that's because it takes several nanoseconds for the light to travel from your face to the mirror and back. So you always will be seeing a version of your face, a version of your body as it existed in the recent past. Several femtoseconds before, however small the time unit, it still is in the past. So that's kind of crazy. So we talk about the reflection of light. We're talking about rays of light, right? Light as a wave. The waves of light traveling, hitting a surface, and bouncing off. Now, it turns out there's two types of reflection. The first is called diffuse. That would be an example of any time light hits a dry surface, a non-reflective surface. So you could imagine the asphalt on a roadway. That's an example on a dry day of a diffuse reflection. The second type of reflection is known as specular reflection. Now, imagine that same road, but imagine it's wet, so it's been raining all day, and the cracks in the road are filled with water, and the road essentially becomes a smooth surface. See this because when a road is wet, normally you wouldn't see the headlights reflecting off the road. But excuse me, here's a wet road, and so what we get is we get specular reflection. And so specular reflection can also be seen here in this image. Here we have a very smooth surface, and so what's happening is light from the sun is coming in, it's hitting the mountain, it's reflecting off the mountain, off the lake surface, and coming back to your eyes. So you can imagine a ray of light from the sun hits the mountain, bounces off the lake there, and then heads to your eye, right? And so because it's a smooth surface, the beams of light that hit the mountain stay together, and they give you a very focused, a very clear image in the lake. And that is the idea of specular reflection. So what does light do when it hits a flat surface? Well, to make our life easier, in high school physics, we're only going to look at specular reflection. So here's light hitting a mirror. We see something very interesting. And this interesting thing is that light comes in and bounces off like this. And this is known as the law of reflection. So to understand the law of reflection, I need to define three things. The first is the angle of incidence. First term is the angle of incidence. And this is the angle between the incoming light ray and a line drawn perpendicular to the surface. By the way, we're going to refer to light, or I'm going to refer to light as rays, okay? So like Ray Charles, rays of light, sorry. The incoming light ray strikes, if you draw a line perpendicular to the surface of the reflecting surface, the angle between the incoming light ray and that line perpendicular to the surface, which is called the normal, is known as the angle of incidence. This angle is known as the angle of reflection. And our second angle is the angle of reflection. That's the angle between a reflected ray and the normal. So that's this angle right here. So the law of reflection, very easy. It simply says that the angle of incidence equals the angle of reflection. So this is the angle of incidence. It is equal to the angle of reflection for any reflection off of a flat surface. Okay, so this is the law of reflection. What does it mean? Well, let's take a look at how an image is formed in a flat mirror, and then we'll talk about the law of reflection. So let's take a look at a pencil that's in front of a mirror like this. A couple things about images. To find an image in a mirror, one only needs to draw two rays. The first thing is only two rays of light are needed to, and I put this in quotes, find an image. So if we look at the pencil, and knowing what we know about the law of reflection, I could do this. I could draw a line straight off from the tip of the pencil, and we know since the incoming angle is 0 degrees that it's going to bounce off straight back. Okay? We would call this ray the reflected ray. Ray 2 I can draw coming down at some angle, and I know that it will bounce off at an angle equal to the angle of incidence. Now, if you imagine your eye is out here, your eye actually sees the two reflected rays, this ray and this ray, and it finds the pencil at the point where the reflected rays would meet behind the mirror. And so I can trace these rays back, and these are known as virtual rays. Right? These are virtual rays. And if I trace the two virtual rays back, my eye sees the pencil tip as being right here, behind the mirror, right there. It also turns out, another interesting fact about mirrors, so it also turns out that object distance equals image distance, and this is just for flat mirrors. Later, we're going to curve mirrors. We're going to take a look at curved mirrors like you would see in a fun house, and we'll see that that's not the case. But this object distance from the object to the mirror, that distance equals the distance from the mirror to the image, right? So they're equidistant apart. In addition, object height will equal image height for flat mirrors. The last thing for flat mirrors is that images are reversed. The front of the word is furthest behind the mirror, like we would expect, and the letters closest to the mirror are also closest to the mirror in terms of the image. So we see that all three of these are still observed. Also notice the angle between the image and the object are the same, which if we were to draw and say this is the normal line, we see this angle here and this angle here are the same. And so the law of reflection is even obeyed in our mirror image situation. So how does the mirror work? How does it create this image? Let's take one last look at a couple animations that might help explain this phenomenon. Before we move on, I just want to make sure I give you this vocabulary word in case you hear it. This image that's created in a mirror is known as the virtual image. Okay, so when I talk about the image, you can imply that I'm talking about the virtual image. So we'll first start with a little animation showing our law of reflection. The law of reflection here, angle of incidence, the incoming light beam, is equal to the angle of reflection, or the angle between the normal and the reflected ray. Okay, so how does an image form? So here we have two situations. We've got this clown, here's the mirror, and here is his virtual image. So notice as the animation goes, I could see that depending on what part of the clown I'm looking at, the light beams, let's pause this here. If I pause it while we're looking at his eyebrow, right, I see that the angle of reflection is observed in all these situations so that the reflected beams go off at this angle. But remember, the eye, which is on here looking at the light, right? When you look at a mirror, your eye's on the left-hand side of the mirror in this example. They all trace those rays back, and they see the virtual rays, and the virtual rays all converge or come together at a point somewhere behind the mirror, and that's where your mind tells you the left eyebrow is of the clown, right? We can see the same situation here in this animation. Depending on what part of the man I click on, right, I can see different images in the mirror. So if we look at the light, how does that image form? We can see the angle of reflections obeyed. If you trace the virtual rays back, they meet at a point behind the mirror. If we click on a different part of the man, the angles change, but law of reflection is still obeyed, and we see the light rays converging and forming a virtual image because of these virtual rays that our eye places behind the mirror and and our mind actually puts the image behind the mirror. There's nothing back there, but our eyes tell us there is. So that's the crazy, awesome thing about mirrors, is that our mind tells us something's there, even though it's not. So I hope that was fun, and I'm going to end with 2 questions on the next slide for you to ponder. Here's 2 questions to wrap up this video. In the next video, we'll take a look at a practice problem where you get to draw some ray diagrams. So here we have the sun at midday, high in the sky, and the sun at 7 p.m. Go ahead and read the question, pause the video. The question is essentially asking, why when the sun's here does this guy not see a reflection of the sun in the windows, but when the sun is setting, he does? All right, so hopefully you pause the video and you can see the law of reflection is all over this question, right? The law of reflection says that the angle of incidence is equal to the angle of reflection. So we see when the sun's at high noon, that all the incoming rays that can possibly hit the window are at an angle so that they won't be able to reflect to the boy. And that one's even incorrect. That one should have been going down like this, right? However, at 7 p.m., if we go backwards, let's get rid of those. At 7 p.m., the light rays can bounce off the sun, and we see our law of reflection is obeyed. If we draw a normal line to the surface of the mirror, we could zoom in on that. Whoop, I went too far. And if we zoomed in on that, we would see that the angle of incidence right here would equal the angle of reflection, and so he's able to see the reflection of the sun in the windows. And then we'll end this with this one. Go ahead and read that, and I'll let you answer that, and we'll talk about this in class. Hope that was fun.